All right, welcome to the Explainer. Today, we're going to talk about something you use every single second you're on a computer, but probably never think about, the file system. It's the ultimate unsung hero, this smart librarian for your hard drive, whose entire job is to keep every single thing in perfect order.
I mean, really, have you ever stopped to think about it? You hit save on a photo or a document, and poof, where does it actually go? How on earth does your computer find that one specific file out of maybe millions and pull it up in less than a second?
Okay, to get this, let's use an analogy. Imagine your hard drive is just a massive, empty warehouse. Now imagine you've got millions of boxes. Those are your files. And you just start chucking them in there. No rhyme or reason, no aisles, no labels. It would be absolute chaos. Finding anything would be impossible. Well, that digital mess is exactly what a file system is built to prevent.
So who steps in to stop this digital anarchy? Well, let's call it our smart librarian. This isn't a person, of course. It's a system, and it's the genius manager of that chaotic warehouse whose one and only mission is to know precisely where every single byte of information is at all times.
Now, on the surface, this is the stuff you already know, right? We see the main drive, like your C drive. That's the library building itself. Then we create folders, which are just like shelves for organizing everything. And inside those folders are our files, the individual books on the shelves. Simple enough. But that's just the stuff we can see. That's the nice, neat organization we interact with. The real question is, how does our librarian know the physical spot in that giant, messy warehouse where every single book is actually stored? This, my friends, is where the real magic happens.
You see, the librarian doesn't just wander around the warehouse aisles looking for your file. No way, that would be incredibly slow. Instead, it has a secret weapon, a super detailed index, a master list. This is the brain of the whole operation.
Because here's the thing, your hard drive isn't just one big empty cavern. It's physically divided into millions, sometimes billions, of tiny little storage compartments. We call them blocks or sectors. And a big file, like a high-def movie, is way too big to fit into just one of these little spots. So it has to be broken up into thousands of tiny pieces.
So, let's walk through it. The moment you hit save, the file system, our librarian, springs into action. First, it shatters your file into all those little pieces. Then, it finds empty blocks anywhere it can on the drive to stuff them into. And now, for the most crucial part, it meticulously records the exact address of every single one of those pieces in its secret index.
So now, when you go to open that movie, your computer basically asks the librarian, hey, where's my awesome vacation movie? The librarian doesn't go searching the whole warehouse. It just flips open its index, finds the entry for your movie, and bam, there's the list of every single block address. It hands that list back, and the computer zips around, grabs all those scattered pieces, and puts them back together in the right order for you to watch. It's a ridiculously complex dance that happens so fast it feels like magic.
Okay, so not all librarians are the same, right? You'd have a different kind of librarian for a kid's public library than you would for, say, a top-secret government archive. Well, it's the same with computers. There are different kinds of file systems, and they all have their own unique rules and specialties.
Let's take two examples. You've got FAT32. He's the old-timer. He's super compatible, which is why we still use him for USB flash drives that need to work in pretty much any device you plug them into. But his big weakness? He can't handle any single file that's bigger than 4 gigabytes, a real problem for modern video files. Then you have NTFS. He's the modern pro for Windows. He can handle absolutely massive files and comes with all sorts of extra perks, like better security and features to prevent data loss.
So, you know when you format a drive, ever wonder what you're actually doing? This is it. You're not just wiping the drive clean. You're literally firing the old librarian and hiring a brand new one with a completely different set of rules and a fresh, empty index book, ready to start organizing from scratch.
All right, we've covered saving files and organizing them. But now, for what might be the most surprising part of our librarian's job, what happens when you tell it to get rid of a book for good?
So you do it. You drag that file to the recycle bin, and then you click Empty Recycle Bin. It's gone forever, right? Well, not quite. The truth is way weirder and honestly a whole lot more efficient.
See, when you tell the librarian to delete a file, it doesn't waste energy running around to all those thousands of little blocks on the hard drive to scrub the data clean. That would take forever. It does something much, much sneakier.
That's it. That's all that happens. The librarian just opens its index, finds the entry for that file, and just crosses its name off the list. The file instantly becomes invisible to you, and all the little blocks that held its data are now marked as available. But the data itself, the actual ones and zeros, they're still sitting right there.
This is mind-blowing, right? Your deleted file is still physically sitting on your drive completely intact, at least for a little while. It only gets truly destroyed when you save a new file, and the librarian needs those blocks to store something else. And this is exactly how data recovery software works. It just ignores the librarian's index and scans the drive directly, looking for recognizable file data in those blocks that are marked as empty.
So there you have it, the file system, the silent, brilliant, and incredibly efficient librarian that turns total digital chaos into perfect, instantaneous order. So now we know how our data is managed right here, on our own machines. But that just opens up an even bigger question. How does all this perfectly organized information leave our computer and travel across the entire globe in the blink of an eye? That's a journey for our next explainer. Thanks for tuning in.